Sorry, I have a
Oh,
question. All
we're
right.
live, Pam. Sorry.
Well, all right,
No,
awesome.
that's this is the beginning of the show for our first ever JavaScript Air. We're super excited to get started on this new live broadcast podcast. So today we're going to be talking about the past, present, and future of JavaScript, and we're really excited. But before we get into it too much, I'm going to give a couple of shout-outs to our sponsors. So first, Egghead.io, they're our premier sponsor, and they have a huge library of bite-sized web development training videos. Check them out for content about JavaScript, Angular, React, Node, and a bunch more. Then Front-End Masters is a recorded expert-led workshop with courses on advanced JavaScript, asynchronous, and functional JS, as well as a lot of other great courses on front-end topics. Actually, Kyle Simpson has a couple of courses on there. I highly recommend you check those out. And then finally, Track.js. Track.js reports bugs in your JavaScript before customers even notice them. And with their telemetry timeline, you'll have the context that you need to actually fix them. Check them out and start tracking JavaScript errors today at trackjs.com. Cool. So during the show, if you're watching live, you can go to Twitter, and if you have any questions, use the hashtag JSAirQuestion, and we'll address your questions at the end of the show, live during the show. And just a couple of general announcements. Remember to follow us on Twitter and Google+ to keep up with the latest, and we're also on Facebook. And next week's show is the same time, same place on learning and developing JavaScript. It's December 16th with Ashley G. Williams and Kyle Simpson. So it's going to be awesome. Let me go ahead and introduce our panelists really quick. We'll have another show later to talk about how awesome these panelists all are. So for today, it'll just be names and faces, so that we can have some time to chat about JavaScript. It's going to be awesome. So when I say your name, make sure to unmute yourself, wave, and say hi so everybody knows who is who. So we have Dan Abramoff.
Hello.
And Brian Lunsdorf.
Yo.
Kyle Simpson. You made a finger gesture. I'm not quite sure what it was, but I'm sure it was awesome.
No gang signs, please.
Yeah. And then we've got Lynn Clark.
Hey there.
And Matt Zabriskie.
Hello.
And Pam Sell.
Hello.
And Tyler McGinnis.
Hello.
And so that's our panel for this show. My name is Kent C. Dodds. I am the host, and totally love this community and JavaScript in general. This is going to be awesome. So let's go ahead and give our guest some airtime really quick. Brendan, could you introduce yourself to our viewers and listeners and tell us who you are, what you do, and what you're up to now?
Hi, I'm Brendan Eich. I created JavaScript in 1995 in a mad rush. I've been making up for it ever since. I founded Mozilla with other people in 1998, and I'm doing a startup called Brave Software, brave.com.
Do you want to chat about that startup? I haven't heard of that before.
We're still stealthy, so you'll have to wait. But there's a MailChimp form you can enter your email into there. And there's an Easter egg if you are diligent about view source.
Snap. I'm pretty sure that we're going to get a lot of those Easter eggs uncovered. That's interesting to me.
It's not an Easter egg anymore, I guess. I blabbed about it.
Yeah. We know the Easter Bunny has hidden something. Cool. So let's go ahead and get into the content of our show, Brendan. We want to talk about JavaScript in general. This show is all about JavaScript and the web and some of the amazing things that you've done. Like, Brendan, you created my job, and I just want to personally say thank you. My wife and children eat and are clothed because of the work that you've done. So thank you very much.
Who knew?
Yeah. So, Brendan, I know that you've told this story probably 100 times. Please, 101 would be great. For our viewers, could you briefly talk about where JavaScript came from, and where did you come up with the idea? What was the original intent?
Sure. So, I have to go back a little bit in time. I was at Silicon Graphics, SGI, in their glory days from 1985, before they IPO'd, to 1992, when they become a very big company. And I left, but I knew some of the early people and the founder, Jim Clark. And so when he did Netscape, he and one of the SGI people he picked up, Kip Hickman, tried to recruit me in spring of 1994. And like a big idiot, I said, no, I've got to keep working on my startup that I did in between SGI and Netscape called MicroUnity, which you might find some references to. George Gilder wrote about it in Forbes ASAP. It was one of those early mid-90s do-everything rock band startups that was trying to innovate in semiconductors to software to beyond. And it, of course, as Clark pointed out to me when I joined Netscape, was likely to fail because when you do 10 hard things and the odds ratio for each of those 10 hard things is independent, the total odds ratio of success by the multiplication principle is the product of all those fractions. So 1 in 10 odds for each of those things: semiconductor, new microkernel, new instruction set architecture, new digital signal processing, analog and digital circuits on the same chip, new user code model for doing what we now think of as superscalar and SIMD. That's like 1 in 10 to the 7th or 10 to the 8th odds of success. So MicroUnity was not going to work. It had a lot of patents, so it still made a lot of money for some of the people, not for me. But I stayed there in 1994 like an idiot, and when Netscape friends called again in 95, I went. And the reason I went was because they said, come on, out to the coast, do Scheme in the browser. And I was already out in the coast, actually, but I wanted to refer to Die Hard there. So I came to Netscape to do Scheme in the browser. But when I got there, they said 2 things to me. They said, 1, oh, we can't hire you into the client, the Netscape Navigator team, because we're short of headcount, and we'll hire you into the server team instead so you can work on HTTP 1.1, or what they hoped became 1.1. And, oh, second, oh, we're doing a deal with Sun Microsystems to integrate Java into Netscape, so we're not sure we want to do Scheme in the browser anymore. And that was kind of a drag. So I worked for a month from April to early May in the server team with Rob McCool and Mike McCool, and the Cool twins, who wrote NCSA HTTPD, which through a fork became Apache, and Ari Luotonen, who did the Netscape proxy server. And we actually did interesting things using kept connections. We tried to multiplex streams onto HTTP 1.1. It was a lot like Speedy, but it was way ahead of its time, and it wasn't going to happen. And for better or worse, I switched to the Netscape client team in early May, and I wrote JavaScript's prototype, the Mocha engine, in 10 days in May 1995. And it wasn't Scheme. It was not Scheme in the browser, of course. It had to look like Java. It had to be done quickly, because a lot of people at that point said, well, do we really need 2 languages? Well, why not just Java? Or will developers understand that there's a second language? And critically, Bill Joy of Sun Microsystems and Mark Andreessen, co-founder of Netscape, said yes, they will understand, because it's like Visual Basic was to Microsoft Visual C++ in the Windows stack at the time. You need a more accessible, easy-to-use language. You can buy by the yard. You can start using line by line. Anybody can program it. You don't even need to be a programmer. It's very approachable. That's for the order of magnitude or 2 larger population of designers and amateur programmers who are critical in an ecosystem to building, let's say, apps or web pages. And so Mark and Bill Joy got it, and that's why I did the 10 days of crazy implementation to prove that it was a viable idea. They also gave me another constraint, which was, oh, we want to have this in the server side for our Livewire sort of PHP-like thing, something that's programmable in the Netscape server, the HTTP daemon, that can hit a database, put some data through a template, and generate some HTML, have a little bit of scripting on the server as well as the client side. They wanted an engine for that, and that's what the Mocha engine was. In particular, that's why I wrote a bytecode interpreter and compiler to bytecode from source. So that's what the genesis of JavaScript was. but it was called Mocha, and then LiveScript because we couldn't get Sun to sign a trademark license until December 4th, 1995, when Bill Joy, who believed all the way, said, I'm going to sign this as Sun's founder. Nobody else, I think, wanted to do it. The next day, I think I heard his name was Mud. James Gosling and all the Java people were like screaming, cursing, and wanting to kill Bill Joy because he signed this trademark license to allow LiveScript to be renamed JavaScript, which, as Douglas Crockford told me when I met him like 6 years later, said was a huge marketing scam, and he was right.
Awesome.
So I have a question, Brendan. Hi.
Hi.
So like many functional programmers, you wanted to write Lisp and then they wouldn't let you. So what do you think about ClojureScript and bringing Lisp into the browser?
I'm in favor. And I should also note something I showed at .js in Paris 2 days ago. The WebAssembly proposal, which is going forward through all four top browser vendors, has an S-expression syntax, not for downloading because that's inefficient. It's probably less efficient than even JavaScript source. But for view source and tooling, it's Lisp in syntax, in its clothing. So yeah, the circle is now complete.
I had a question too. I was wondering if this was your first crack at writing like a bytecode interpreter. I heard you had hung around Stanford reading white papers on the subject, but you might have. Is this your first try and it just worked?
No, I wrote. So I was a physics major for 3 years at Santa Clara University, and I was frustrated because this was the 1979 through 82, and it was an awesome time in computing, right? The Apple II was born in the late 70s. There was still a lot of people building computers from scratch. And yet I was doing physics, and my department chairman would say, when I asked him about summer job options, he would say, have fun mowing lawns. So also physics, I think, stagnated a bit. It's a different topic I won't get into here. So I ended up being a lab assistant on DEC 2060 and VAX systems, which I loved, and Unix. And I switched to math computer science in my 4th year, and I started writing immediately. I loved the theory of formal languages, parsing regular languages, regular expressions, lexical analysis, and parsing and compiling. So I started writing my own parsers, compilers, parser generators. At the time, in the early 80s, there was a sort of arms race to generate efficient parsers from certain kinds of grammars. The LALR1 grammars in particular were hot. And I wrote the parser generator, and I did a lot of hobby implementation of programming languages. And I was inspired throughout the 80s by Brian Kernighan and P.J. Plowger, I think his name is pronounced. And then Kernighan and Pike did a book on Unix where they had a little toy language called Hawk, classic Rob Pike language. And even before Hawk, there was Awk, AWK, Aho Weinberger Kernighan, I believe. And I had the source through academic or later through SGI commercial Unix licenses. So I studied all these things. I studied all the ugly C code that was used to implement these things. I was a C programmer. I was a kernel hacker as well as a programming language buff. So I had implemented a lot of hobby languages. And then at SGI at some point, after doing a lot of kernel hacking, we realized that you could do a network management software stack on Ethernet, 10 megabit Ethernet at the time. And one of the things you wanted was to turn on promiscuous mode, capturing packets on the net and dumping them. So I wrote a packet filter language that could be efficiently compiled into the kernel. There was a Berkeley packet filter in Berkeley Unix that used bytecode. I wrote something simpler at the behest of one of my mentors and colleagues that compiled a general expression language over the header fields of the IP protocol, the TCP protocol, or UDP, into a short set of mask and match, sort of bitwise filters. And that was fun, and that turned into a product that SGI sold, and I ended up writing another compiler for that took a general protocol description language that I designed that could express TCP/IP or AppleTalk or DECnet, and that allowed my colleagues at SGI to write protocol descriptions in a higher level declarative language, and my compiler would turn those into decompilers, pretty printers, and packet filters for those languages, those protocols. So this turned into a network management product. So I had some experience writing these things. And then at MicroUnity, I wrote an MPEG-2 editor that would parse the MPEG-2 video multiplex bit stream and turn it into something you could edit and then turn back into a bit stream. So we could generate, test inputs for our video decoder. Because MicroUnity, but in addition to doing 10 hard things at once, was trying to build a set-top box to decode video, what you might think of as like a streaming video before its time, MPEG-2. So I had experience writing compilers and parsers and lexical scanners, and that allowed me to do JavaScript extremely quickly. Like in the first day, I'd knocked out the sort of C-like parser because I knew the C grammar by heart. I knew all the weird corners of it, like the adjacency and the precedence hierarchy of the logical and the bitwise operators, which is purely due to evolution from the B language, where there was only one set of such operators that did both bitwise and logical duties.
Right on. So it's not your first rodeo.
No, not at all.
Brendan, you're on a totally different plane from where I am. I feel like so low right now. It's really.
Ken, I mean, writing a compiler is within your reach. You can do it.
Actually, yeah, getting to be a popular design pattern these days with all the functional stuff, like, and DSLs coming back and everything. It's exciting.
Yeah, write you a DSL.
That's right. The people who use Scheme for pedagogy encourage people who learn it to early on write their own language processors, and I think it's great.
So I had a question. If there were a parallel universe where you were able to have done Scheme in the browser, where would the web be in that parallel universe today?
It might. So I don't know. I mean, these are hard. There's so many variables, but it might not be that far off from where it is. The syntax may not matter as much. Scheme, is beautiful and minimal, and very few special forms. And the flip side of that is you end up writing a lot of industrial Scheme code using macros. So you need a hygienic macro system, and then you end up writing macros in a way that may not be portable to other environments where they don't load the same macro libraries. So you would have to include macros, I think, in order to get the full effect. Things like call CC, call with current continuation, which is like functional goto. It's where you capture your current program state and then reify it as a function that can be called to jump back to that state. That's awesome, but it's often too low level, so people write macros in Scheme on top of call CC, and those macros become much more understandable and easy to use correctly across a large team of programmers. And then, because Scheme is not sufficiently standardized, let's say, there are standards, obviously, but different industrial uses of Scheme I've heard about, I've never worked directly with Scheme, end up reinventing the wheel differently. And it's sort of like C in the early days. You had to have a standard library, Studio and stdlib, what became stdlib, and you had to have them well implemented, and they sometimes didn't agree. Back in the 80s, and it was rough. Things were different. Things did not agree.
I have a question on the whole design side of the language. It's pretty common for people to level the claim against JavaScript that there are mistakes or bad ideas in its design. Some of us maybe sense that pain, and others of us maybe don't see that as much. But I'm curious from your perspective, do you feel like there are language design decisions, mistakes, or do you think it's more a question of needing better resources to learn JavaScript the way it was designed?
So first of all, there were clearly mistakes. I worked 10 days without much sleep, and even then I made mistakes afterwards based on early inside Netscape user testing. So I've talked about this a lot in my writing and speaking. There were mistakes, for sure. And you read, Dennis Ritchie wrote a very humble and educational history of the C language, and he admitted there were mistakes and sort of path-dependent errors or consequences of evolution, like I mentioned, the bitwise and logical operators being adjacent in precedence. And you just can't help some of these things. So it's kind of absurd to say no language should have mistakes. All languages have mistakes, including our fine English language, a Germanic language that it's heavily been influenced by the Norman conquest of 1066, right? There's just English is an ongoing mashup between different languages, and it has irregularities and what look like mistakes to people who speak other languages. So, JavaScript had mistakes, but it also had, I think, a sort of natural language degree of sort of magic to it. It's the property that Larry Wall actually aspired to with Perl, which is this sort of do what I mean quality. And it's very risky to try to design a language that has that property, because often it'll do what you don't mean, and you won't get an error message, and you'll only find it if your test coverage is good enough. But when it works very well. So you're right, there was some intentional design and there were some mistakes. I mean, the one I talk about rather explicitly, like on Stack Overflow, is that the double equals operator will, given two operands of different types in the type of sense, will try coercing one or the other or both to a comparable type. And that can lead to trouble. It makes that double equal operator not be an equivalence relation in the mathematical sense. It's intransitive in particular. There are other problems to do with nans that I won't get into, but that's kind of a corner case, and sign 0, negative and positive 0. But it means that, the quoted string quote1 quote is double equal to the number 1. And that's intentional, but not in my original design. That was after the 10 days. This team that was doing Livewire, the server-side embedding of my engine, were dealing with a lot of HTTP headers and form data in HTML forms that had numeric strings, and they wanted to make it easy for the programmer to compare quote 1, quote 2, 1. And like an idiot, I gave them what they wanted. And that's why I changed from my original design, which is very C-like. It said if the types differ, the thing's not equal. Forget it. And that's what led to the triple equal operator. When we started to standardize JavaScript with Microsoft, everybody in the room, Guy Steele was there, one of the creators of Scheme, along with Jerry Sussman. We all said, "Oh, this is not good. This is kind of a messy operator. It's sloppy. It converts. It's not an equivalence relation. It's not transitive." Guy was actually philosophical. He said, we can add another operator. Common Lisp has 5 versions of EQ and EQL and so on. And the Microsoft guy, Sean Katzenberger, said, well, we can add this triple equal operator I've been experimenting with. And I had been saying, let's make a break. Let's do JS 1.2. This was 1996 or early 97. Let's just change double equal to be strict. And Microsoft, trying to gain market share on Netscape, couldn't stand for it. Sean said, no, we can't break compatibility. People are using double equal in a sloppy way. Let's add triple equal, and that's what we did.
So, Brendan, I think that you've called yourself an idiot at least 3 times on this podcast. That makes me feel a lot better, I guess, about myself, but I don't think you're an idiot.
Well, I don't mean to be pretending to be humble. I think that what I did then, in particular, was try to please people by doing things that turned out not to be sound. And, maybe in the long run, they were the right decisions, but I think it's better to be strict than sloppy, and it's better to make people write type conversions explicitly than implicitly. So in that case, I was an idiot. Otherwise, not.
Makes sense. It's actually really interesting.
Yeah, well, I wonder about, you said you did some early user testing, and it sounds like a few things might have been going on there in that, classically in user testing, what you give people what they want is not necessarily what they need. And then a secondary thing of, how enterprises can destroy the best played plans with, everyone's opinion and the opinion wars.
Both are true. And, Perl at the time had, and still has, Perl 4.5, has a sloppy sort of double equal operator. It will compare unlike types by doing conversions. It doesn't go as far as JavaScript. It doesn't try to convert string to number. String to number is obviously a lossy comparison because the string foo is not a number. So what happens in JavaScript is it turns into the not a number value of IEEE 754, and not a number is a number, actually. And it's in all our hardware. It's in Java. It's in C++. It's in C. It's in the floating point units and short vector units of all our hardware. So I went a little far, I think, in converting arbitrary strings to numbers, where Perl didn't. But for other cases, like Booleans and empty string to false and things like that, JavaScript and Perl are the same. And this is something I point out on Stack Overflow. And I often joke, oh, it was the 90s, people were sloppy then. But maybe that going a certain distance in that direction was okay. It's hard to, like I say, it's hard to rerun reality with different parameters and see what would have happened.
Since you're specifically on the topic of strings to numbers, I wonder if you remember or could recount for us one specific case, which is that the empty string, when coerced to a number, becomes 0. Do you know what the genesis for that or the reasoning behind that was?
Yeah, I think, as I mentioned, the Perl does that too, and a lot of languages that deal with form-filled input do that because they want to allow the shortest possible input to turn into the number 0 without an error, without nagging the user to type 0. And so you end up, in a lot of cases, with a defaulting sort of a union type where it's a very it's a specific kind of refinement type where it's either a number or the empty string, which means 0. Obviously, I went further and I let any string convert to number, and I say that's a problem. But that particular case was quite popular and remains in a lot of languages.
I have a question which is not exactly about the very beginning of JavaScript, but more about the middle. And the question is that when did you start noticing that people create real applications with JavaScript? Because in the beginning it was just a language to like change a rollover menu or something like that, but then people started building applications. So how did that happen?
Great question. I talked about this at least since this past summer in Prague. I talked about some early single-page applications built in 1995 and 1996. Netscape 2 was a real platform push as a browser. It wasn't just a browser. It was a platform that scared Microsoft. Microsoft had already offered too little money, I think $100 million or something, to Netscape in late '94, and the Netscape principals like Jim Clark and Jim Barksdale said, get out of here. And then they knew Microsoft was coming after them. Especially when they launched Netscape 1 in fall '94, and it started getting huge traction, and it had, what in hindsight was very insecure, secure sockets layer for e-commerce. But it was obvious that the web was going to sweep aside proprietary systems like AOL, CompuServe, and Microsoft's prototype sort of knockoff of those systems, codenamed Blackbird. And so people started building applications right away because in Netscape 2, we weren't just doing JavaScript, we were doing frames and frame sets. Eric Bina, Mark's coding partner on Mosaic, and first floor Netscape guy. I liked working with him quite a bit. Eric's retired from programming, as far as I know. I think he's a horticulture second degree holder from UIUC. His wife's a professor there or somewhere else, and he's raising plants and doing biology experiments. But Eric did frames and frame sets, which allowed tiled user interface like AOL had in the day. And Mark was very excited about this. And with JavaScript added to frame sets and frames, you could do things like JavaScript :URLs for link href attribute values. You could do on-click handlers. You could automate, even locally without a server, response to a click. You could also do things like XHR by forcing a submit of a hidden form in a 0 width and height frame in a frame set. So you could do background I/O. You could do async I/O. So people like somebody named Bill Dortch, who I recently reconnected with on Twitter, he had a company called Idaho Designs, like Idaho with an H in front. And he built single-page applications. And the one I showed this summer and then talked since then is in the Web Archive from 1996, webarchive.org. It's an art gallery of, I think, mostly Idaho resident artists, sort of Western art. And it's totally a single-page application like we would build today, except with frames and frame sets, which we do not use now. We use iframes or divs or whatever, table layout. And it had its own data that it downloaded that was a catalog of the artist's works. There was no JSON then because I didn't have time until '96 to start doing JSON, or what became JSON, which became standardized later in ES3. But you could call new catalog or new artist to call your own constructor, which would then assign to this dot title and this dot year and this dot price and this dot whatever description to create a catalog of artists' works, including the images that showed the works. And so there was this entire downloaded data set for the art gallery, and the single-page application allowed you to navigate through it. And that was all in 1995 and 96. So it didn't start with Ajax in 2005. This stuff was actually prototyped in 95 and 96.
So going back to those first 10 days, did you... I've always wondered, as someone's kind of doing something that's going to like fundamentally change the world, did you realize that this was going to be big? Did you have any really thoughts that this was going to be big, or was this kind of just something that you were doing to fulfill like a job task or something?
Well, to tell the truth, I knew it was important because timing is everything in life, right? If you did something great, I mean, there are awesome languages that have been done at the wrong time in the wrong place. Walter Smith, I believe, did Newton script, which I wasn't aware of, but shows some similarity to JavaScript through convergent evolution just by being in the same field of force, like having been in the wake of self and thinking about problems in similar ways. I ended up making something that had some commonality with Newton script, and I knew nothing about Newton script. Years later, I found out about Newton script, and Walter Smith, did it, and the Newton failed, right? It was a joke in the Simpsons episode where the bullies at the school assembly hear the nerd Martin ask us some suck-up question to the Principal Skinner, and one of them says to the other, "Take a note on your Newton. Hit Martin later." And the Newton's handwriting recognition was so bad, the Simpson authors were joking about it because he writes "hit Martin later" and it gets translated to "Hi Martha Bake." and then the bully gets so mad he chucks his Newton at Martin the nerd and hits him on the head with the Newton. The Newton failed, and Walter Smith went on to work at Microsoft, I think. I don't know what he's done. He's probably done very well. But he didn't keep working on it. When I was doing JavaScript, I knew it was at the right time and the right place to not be a Simpsons joke. It was going to be big. How big, I didn't know because it was so underfunded. It was just me. There were a lot of quirks and warts and bugs. There were a lot of bugs, frankly. But my cubicle mate, Jeff Weinstein, whom I knew at SGI and MicroUnity, the startup I did between SGI and Netscape, at one point we were talking to each other about what's going to happen as Netscape starts to go down. What are you going to work on? Jeff was doing security. He took over the secure sockets layer, the crypto module and protocol code from Kip Hickman, my friend from SGI. And Jeff said, "What are you going to do?" And I said, "I'm probably going to be working on JavaScript for 20 years. And I was right. So perseverance matters. If you're in the right time and it's going to become this thing that spreads virally and takes over. Like I beat VBScript. If I didn't do it in a rush, it probably would have missed Netscape, not only Netscape 2, but as Jamie Zawinski documents well on his blog, Netscape 3 was originally going to be Netscape 2.1. And what was supposed to be Netscape 3 became Netscape 4 and was a cluster F of colossal proportions due to Netscape first 4 people burning out and Netscape management acquiring a company that didn't know how to do browsers and giving them the keys to the kingdom. So Netscape 4 was late, and Netscape 3 was still my Mocha engine. If I hadn't done that work in 1995, I probably would have missed the window, and it's, I think, probable that IE3 and then IE4 would have pushed VBScript so hard that without JavaScript, you'd be writing VBScript. We would be having a VBScript hangout, and I wouldn't be here.
Well, I'm glad that you're here.
I have another question, which is, it feels like in the past 2 or 3 years, there's been more evolution in JavaScript world than in the past 10 years. So what exactly changed? I mean, apart from browser vendors implemented fast engines, what has changed in terms of organization and working on JavaScript itself?
So the big change for me, and I've talked about this recently too, the last like 3 or 4 years, I talked about a strange loop in 2012, I believe, is that the developer community, like 10 years ago, would say, it was a much smaller community, I want to write pure JavaScript. Like the fake Twitter account RealDonaldJS, they would be saying, I want to make vanilla JavaScript great again. And they would not want to run any tools. They didn't even like running a linter. They certainly didn't believe in build steps. They did not have the automation we have today that we take for granted, like Gulp. That's changed, and I think now compiling, especially like Babel.js, is here to stay. And it allows us to smooth over the differences in recent browser versions, as well as handle some older versions. And since browsers are now all evolving faster, even Microsoft is evolving faster, it's going to continue to be an important factor. So compiling, even if it's from a ES6, which is a standard, like a standard from the future, it's now finalized, modular errata, is here to stay. And that's sped up the pace of evolution dramatically. And beyond that, of course, we have multiple languages compiling to JavaScript. And then there's WebAssembly, which I'm sure we'll talk about later.
Since you're talking about transpilation, so we saw with ES6 that most of the features in ES6 were expressed in terms where they could be pretty directly transpiled to ES5 equivalent. But I've seen several proposals for ES 2016 and beyond that are suggesting features which are basically whole new primitives that can't really be transpiled to older versions. I'm curious your perspective on the direction the language ought to take.
Can you give an example of such a primitive? Kyle?
Yeah, so there were things in ES6, for example, like proxies have no previous thing, so they can't really be transpiled. But there are several proposals that are being talked about that really can't be built on existing even ES6 primitives. So I'm just curious if you have any perspective on that direction of evolution for JavaScript.
Sure. So, by the way, in ES6, there are also not just proxies, but modules have aspects that can't be expressed in ES5, and things like super in classes, class hierarchies. But you know, in every language, there's what you might think of as the kernel semantics, the irreducible set of primitives, and then there are affordances built around those primitives that are composite or you know, composed of primitives together. That's natural. You need a language to be usable. If it only has the primitives, like scheme without macros, it's pretty hard to use. And that's why macros are used, like I said early on, to make affordances usable APIs, veneers on top of things like call CC and scheme. But JavaScript always has had to be usable, so it always has had composite affordances. In fact, because I did it in a rush, I made some of the, quote, primitives, the parts that were irreducible, that couldn't be broken apart into simpler parts, composite. Functions were composite. They were used as constructors and procs, top-level functions, procedures. They were also used as lambdas or function expressions, and they were used as methods. You might think of 4 different forms that could be used to split those out into a narrower set of primitives. Some of them would bind this automatically for you, like in a lexical way, like arrow functions do, or if it's a method, they would bind it in a dynamic way. But I didn't do that. I did functions, and they were big, fat, composite pseudo-primitives, quasi-primitives. And I did it because I was in a mad rush. And I did objects similarly, too. Objects could be like dictionaries in Python, but they also had a prototype chain, so you could get dictionary namespace pollution from the prototype, which everyone knows about. And that was powerful on the flip side because you could use the prototype to add methods and shared constants, mostly methods, and do sort of classy or even purely selfish prototypal programming. So JavaScript needed to have a larger, not only a kernel language within itself that had more reduced primitives that were truly minimal. It also needed to be larger in the sense that it had missing primitives that weren't there at all, like modules. And sure, you can rig up modules, as the CommonJS folks did, and it's great that they did that because we like people paving those, you know, blazing those trails. Let's say we like the cows. I don't want to switch metaphors too much, but the cows should step on the cow paths first before the standards body tries to pave them and turn them into Boston's streets. Because Boston's a nightmare to navigate because they paved the cow paths. But that's better than design by committee, where they often get it wrong and they build a super highway to nowhere. So, so if you buy all those metaphors and can forgive me calling developers cows, I like the CommonJS to blaze that trail, but at some point you have to say, let's add the primitives because they have certain properties that you can't enforce in the dynamic composite form that you created on top of JavaScript's older primitives. So the JavaScript kernel language is growing. ES6 is growing. As you say, proxies are a new thing, couldn't be expressed in ES5. And there's a few more things to add, not many. And I think the kernel language will stop growing at some point. And WebAssembly will also help take the pressure off JavaScript's kernel language to serve two masters, to both be a great language for human coders, where you might grow the kernel language inside JavaScript just for those human coders, and a great language for compiler writers, where you may have completely independent needs that aren't particularly great for human coders.
You said that you think it's going to stop soon. I have to push back a little bit because it seems like there is a never-quenching thirst for pushing JavaScript classes. And in particular, when I was asking the question a moment ago, I was thinking about some of the new proposed things like the privileged or private visibility in class chains, which is going to use, internal properties in interesting ways, I guess I'll say. So do you think that classes themselves will kind of settle down, or is this where everybody's going to shove new features into the language for a while to come?
No, first of all, it's hard to keep shoving new features in it. As a language matures, it just gets more difficult to reconcile them with the existing kernel primitives. And the committee is acutely aware of this because a lot of people in the committee are implementers. And as I said in recent talks, some of them are getting to be a little cranky about all the burden of implementing ES6 features. But what's happening with classes is we're actually codifying not just the pattern that people wrote with function constructors and the constructor pattern, let's call it, sometimes called the prototypal pattern. We're also considering, like Yehuda Katz and Alan Wirfs-Brock, private data proposal, because the engines already do this for the built-in objects, like the DOM objects, and a lot of those objects are now self-hosted, like in V8, with a magic extension language built on JavaScript. They're written in JavaScript with some extra syntactic magic to allow you to reference private fields which cannot be accessed outside of the module or scope in which those private fields are defined, and which efficiently map into directly addressable slots in the object. So I think that's legit. I think that's bounded. It's not going to turn into another endless quest for more object-oriented features. And it really is, in some ways, trying to allow JavaScript to self-host the host objects, the DOM in particular, that always was this word in JavaScript, this magic, backdoor into C++ where you get objects that didn't behave like a vanilla a JavaScript object would. They had private state. They had magic intercession capabilities, getters and setters and beyond. And I think it's fine to extend a mature language with the kind of metaprogramming and efficient private state kernel features that are missing in that regard. I think once you do that, the door closes. So I'm not too worried about this being a runaway train.
Well, how do you draw the line then between, like you're saying, adding those features into language for those, those language affordances for various use cases like the self-hosting, and the WebAssembly stuff? So I'm jumping forward now because I know we want to talk about that. How do you draw the line and say it ought to be added to the language, or here we have this other side door? Maybe some of that stuff should have come in through that door instead.
So there are two ways to answer that. One is, would the human authors of JavaScript benefit in significant numbers from, do they have a use case that we need to serve with better kernel primitives and better affordances that are composite? And I think that actually can be answered independent of the WebAssembly question. And in the case of private data, I think the answer is yes. People even, I talked to people at .js about this, they want not only private data, they want TypeScript or Flow or son of TypeScript. And that's going to be harder to standardize. It may almost be tool time. It could be a separate spec built on top of the ECMA 262 spec. But I think that's legit. But you make a great point. If WebAssembly were here already in all the browsers, certain things, certainly threads and shared memory, possibly SIMD, like the case for SIMD in JavaScript is pretty strong, independent of WebAssembly, but also things like guest host stratification, where you can put a language in WebAssembly that has its own garbage collector but doesn't create uncollectible cycles because it actually hooks into the JavaScript garbage collector or actually just uses the JavaScript garbage collector. That's all on the roadmap for WebAssembly. That probably shouldn't go into JavaScript. And if we had WebAssembly now, I bet we wouldn't be entertaining a proposal for threads and shared memory, shared array buffers in JavaScript. I wrote a blog post in 2008, I think, called Threads Suck, where I said we would never add shared memory threads with data races to JavaScript, and yet we're considering such a proposal, very carefully made, because we lack WebAssembly in all the browsers. But WebAssembly is on a fast track. There's prototypes in V8, Chakra, and SpiderMonkey, and I think, depending on Apple secrecy, even in JavaScript Core. So I bet middle of next year we'll start to see some WebAssembly decoders shipping, at least in nightly builds or flagged, so you can actually generate the bit-coded syntax for WebAssembly, which is much more concise than JavaScript, and load it into the same one VM that everybody implements per spec. And that's where the opportunity arises to do things, new syntax for new semantics in WebAssembly, and not expose that to JavaScript. But this is a sort of tricky, pragmatic, as well as philosophical question. Because we're racing between getting WebAssembly out and extending JavaScript, do you do it in both? Do you do it only in WebAssembly? Some people think JavaScript should have every affordance WebAssembly has. I early on said for usability and human coders, JavaScript should optimize in ways that might exclude things compiler writers want. So I do see a bright line where certain things should only be for the compiler writers in WebAssembly, and those syntactic expressions should not map onto semantics that are exposed through JavaScript expressions.
I have a question about the future. Can you imagine how an application might look in 10 years' time? Like, what is it able to do? Threads and so on. How does that fit together?
Yeah, I think some things are immortal. Like Unix is immortal. In the old days, Unix was processes, not threads, but we had to swallow threads, and threads get overused, but they have some uses. And I'm thinking of game engines that, have to have a big scene graph that's shared among threads that pragmatically farm out the work across cores. And there's no a priori, declarative way to say this part of the scene graph is for this thread and this part is for that thread, or this core and that core. You end up doing it dynamically on the fly. You use sort of work stealing, scheduling, and other techniques. And then you parallelize using SIMD and, of course, the GPU through OpenGL or WebGL. So I think we will see WebAssembly emerge as an important transfer syntax, let's call it, akin to JavaScript. Two syntaxes, one VM. And the one VM is important, otherwise you get garbage collection cycles and you get the cost of guest-host or mutually conflicting host-guest conflicts between two VMs, like the Dart people were facing when they were trying to put Dart VM into Chrome, which they abandoned. So it's a critical evolutionary step for JavaScript to be a language that has a very detailed specification and a common source language which everyone can use, but then to go to a second source language, WebGL, which is a binary language, and have that be efficient and adopted, I think will happen. And a friend at Mozilla said WebAssembly is going to be in the hardware, man, and that I believe. So in 20 years, I bet you'll see some kind of flattening of WebAssembly, optimizing. I don't know if it'll be ARM or Intel. I don't want to speculate that far, or their licensees, but this stuff's going to be here for the long run, and it's going to map to all the hardware features, which means threads, SIMD, GPU, even OpenGL 4.5 or whatever, powerful as it is, doesn't quite get at all the computational power in the GPU, the teraflops of parallel floating point units. So there are things like SpearV and Vulkan coming out of the Kronos group that are worth looking at, that go well beyond OpenGL or the subset that is WebGL, which is itself trying to move to WebGL 2 based on OpenGL ES3. Just extrapolate that conservatively, and you see a world where portable, safe code that doesn't have array buffer overflows or stack overflows or obvious security problems can tile the entire functionality of your awesome hardware.
Hey, Brendan, thank you so much. I think we are winding down on our time. We want to be respectful to you, the panelists, and our viewers, so I think we're going to start wrapping things up. We do have quite a few questions on Twitter for you. So the discussion is not over. So excuse me. The first question that hasn't been discussed necessarily during the show is from Jason Trill. He asks, what are your thoughts on static typing in JS? Will we ever get static typing in the runtime?
So we've debated this in the committee, and we're first of all, we're not going to rush it in because that would be a mistake. We have to have things like TypeScript and Flow, which are static type systems that produce warnings in your tool, but which generally, outside of their checked modes, generate JavaScript that can then have runtime errors that a real static type system would not allow. Global inference, so you don't have to write so many type annotations. We need these experiments to be adopted and used and sort of de facto standardized before we put anything into JavaScript. The other thing I would say, and I said this at .js, is we might end up writing a standard for the type system, but it might not be in the browser. It might be a tool time type system, just like TypeScript and Flow. And that might be enough, because it'll tell you when you've misspelled a property name. It'll tell you when you've made other obvious errors. It'll find even more sophisticated errors using its more sophisticated control flow analysis. And that could be a separate spec from ECMA 262, and that could be enough. What we know from academic research in dynamic languages like Racket, originally called PLT Scheme, which was a academic version of Scheme, was that people have done things like Sam Tobin Hochstadt did typed Scheme, now typed Racket, typed PLT Scheme, and it used the module system to do a statically typed language inside one module, and you could have another module that was purely dynamic, Racket, and when they interact, values could flow through into the statically typed module that would violate the type checker, but they would be wrapped in a proxy, essentially, a chaperone or one of these other Racket proxy-like things, and you get dynamic errors. So you would still not run code that had type errors. You would fail at runtime. Kind of like JavaScript today, where errors are at runtime. So it isn't clear that we can actually benefit by putting the static checker into the browser, into the runtime. It might be best at tool time. It's also the case that when you add the static checker, just like when you add other static metaprogramming like macro processing into the browser, you're going to slow down the browser on certain benchmarks, and no browser vendor wants to slow down on the benchmarks. So it's going to be hard to add the static checker, or I would say even macros like Sweet.js, to the browser, but they might end up being viable tool time standards.
Cool. Yeah, that's a very interesting answer. Thank you. The next question is from Alex Booker. What is, excuse me, was it surprising to see JavaScript on the server, parentheses Node, become so prevalent? What do you think about Node.js in general? And I think that was kind of part of your original plan, right?
Sure. So Livewire was JavaScript on the server at Netscape in 1995. Did not succeed. Netscape's entire business was crushed by Microsoft. Right, the browser became free with IE being bundled with Windows 95 and 98, and Microsoft copied a lot of the Netscape servers, and Active Directory killed the LDAP server that Netscape bought from the University of Michigan, I believe, as a team. So JavaScript on the server is not a new thing, but when Node came out, I think Ryan Dahl, again, timing is everything, hit the right time to make it really simple to create sort of I/O-bound, very efficient services, servers. My Python friends point out that it's easy to make a short Python server, and they're right, but JavaScripters could do it, and people writing JavaScript on the client can then go full stack to the server, and that's super powerful. So, obviously Node was huge for JS and is still huge, and I'm still excited about what can be done there, and it's still evolving.
Absolutely, yeah, and it's totally enabled all these cool tools that that we use that have totally changed the face of front end and back end web development. So I'm excited too. Cool. Next question. I'm so sorry I can't pronounce this name. Shenekel, I think. he asks, do you have any opinions on Swift Lang, or more generally, how do you think about how do you think the divide between apps and browser will go?
It's a good question because a couple of observations. One is that Chris Latner of LLVM and Swift fame, in his personal blog, Apple marketing never would acknowledge this, but in Chris's personal blog, he credited Rust as like the first or second influence on Swift. And I was the executive sponsor of Rust at Mozilla, and both Swift and Rust are built on LLVM, Chris's compiler framework that he led starting at University of Illinois at Urbana-Champaign. So there's something going on with LLVM, kind of misnamed because it's not so much a VM as a compiler backend framework, being a powerful way to cross-compile static languages, or let's say lots of languages that have front ends for LLVM, to the web. That was demonstrated first by Alon Zakai at Mozilla, the creator of Emscripten. But if you think about it, going from C++ to JavaScript or ASM.js or WebAssembly through Emscripten or one of its successors or modes is not that much different from going from Swift through LLVM to JavaScript. So I think that we'll have a general cross-compiler instead of this n-squared problem of different compilers having to map to different target languages, including the web. We'll have LLVM as the central multiplexer for source languages to target languages, including JavaScript and WebAssembly. And that will make Rust even possible on JavaScript as well as Swift.
Very cool. Yeah, the future of JavaScript and the web is bright. Cool. So next question from Vile and Vinio. Yep. Where do you see shared memory multithreading for JS going in the future?
So I said it would happen over my dead body. I'm not dead yet. My friend Lars Thomas Hansen has proposed it. He works for Mozilla, but he's working with Google people. He's proposed it as an extension to JavaScript via shared array buffer and an atomics object, the top-level global object called atomics that has what you might think of as spin locks and futexes, when Linux fast user level mutexes, condition variables, things you can build with those things. Lars is proposing this because WebAssembly isn't here yet, and people want to write Unreal Engine 4 and cross-compile it from C++ and pthreads and OpenGL and OpenAL to JavaScript and WebGL and WebAudio. And for threads, there's nothing right now. Workers are these isolated things with a painful API. So if we added what Lars is proposing and working on with other people, including at Google, to JavaScript, it could be done pretty quickly, but we're in a race with WebAssembly. So part of me, and I really am torn about this, wants to have WebAssembly be the only answer for shared memory threads. But part of me sees the pragmatic appeal of what Lars is proposing, and I don't know what's going to happen. I honestly don't. If WebAssembly gets done fast enough, I think it takes the pressure off everyone to put what Lars is proposing into JavaScript, and that's the perfect example of what I said earlier, that the human coders benefit by leaving out the possibility of data races and shared memory for all time from JavaScript.
Cool. Boy, I'm really sorry. There are a couple more questions. I just don't know if we'll be able to get to them all and still wrap things up. So I'm going to have to pick and choose.
3 more minutes.
If you don't mind staying on, I don't mind keeping it. Anybody can jump off at any time if they like to, but I would like to respect everybody's time. So I'll just ask. I think there's a question somebody asked on the Google Plus Hangout page that I think would be really interesting to hear you answer. The question is, where do you see JS in the next 5, 10, or 20 years?
So, just getting ES6 done, and it's still not implemented fully, though Chakra, which is open sourcing Chakra Core, is like plus 90% done. It's going to be a big deal, and it will take time for people to absorb that. But every time I go to conferences, more and more hands go up when I ask who's using Babel.js. That's going to go for a while. ES7, async functions, async await, great affordances people want. Maybe the private data stuff, we'll see. We'll make sure it isn't the wrong thing. I think in 10 years, it's hard for me to predict. My crystal ball doesn't go that far, but I do think WebAssembly will then start to be used a lot. Like right now, Facebook has a significant number of game studios launching games, a lot of them based on the Unity engine, tool, that are cross-compiled to ASM.js, and with WebAssembly they simply load faster. They load a lot faster because even with gzip, the concise syntax wins. They take less memory when they load because you don't have to expand them into JavaScript or deflate them into JavaScript and parse that. ASM.js is bigger than WebAssembly inherently. So I think that's going to be huge, and that's going to take a while for the ecosystem to absorb. And when it absorbs it, we'll get inevitable requests for more features, like more GPU features. Like WebGL is based on OpenGL ES2, which is pretty limited and old. Not many shader programs, not many features. People want to use the GPU for general computation, so there's a common extension to OpenGL called ARB Compute Shader. That would be wonderful to have in JavaScript in a safe way. But that seems to be beyond our current standards horizon. I think that'll be big in the next 5 to 10 years.
Hey, there's a question on Twitter. I want to make sure we don't miss this. I think this would be really good even to wrap up on, perhaps. Nicholas O'Donnell had asked, Brendan, what are your tips for somebody starting out learning JavaScript? I mean, we've talked about this amazing language and all the future. How do people get into it, in your perspective, most effectively? Do they start with the frameworks? Do they start with the language itself? What are the resources or tips you'd give?
So I was accused by Yehuda Katz on Twitter of being behind the Real Donald JS Twitter account, and Real Donald JS wants to make vanilla JavaScript great again. I am not behind that account, but I do want people to learn vanilla JavaScript. I don't think that they should just skip it. It's sort of like in the old days, people should learn assembly, or in the 80s on, learn C coding at least. And I think there's still value for some people to do even that. But learn JavaScript and learn Node.js and write your own servers as well as clients, write your own gulp customizations, and really learn the sort of the groove of the language. I worry about things like Meteor. I have a friend who works there, Ben Newman from JavaScript standards body from TC39, but these tend to be sort of closed world, sort of enterprise-oriented tools that suck people in. Angular has this flavor too. Not to beat on it. I like compositional libraries. I like programmers to learn the native language before they learn some sort of constrained dialect.
Cool. Yeah, that's a good tip. Thanks, Kyle, for bringing that up. And I think that is probably a good one for us to wrap up on. So we're going to go ahead and we're going to speed through these tips and picks. So if you have more than one tip or pick, just pick your favorite, and we're just going to do one. And then in the show notes in the audio podcast, I'll put all of your picks, so don't delete them from the doc, but just on the show, just pick one. So Brendan, why don't we go ahead and go with you? Have you, I hopefully prepared you for this a little bit, but do you have anything in particular that you'd like to pick, or any tip that you'd like to give people?
Oh, that's a good question. I mean, ES Hint is huge, and we're using it, and there's a great talk by Elijah Manning about how to use it well. That's on YouTube.
Sweet. If you can maybe find that link, and we'll add it to the show notes. ESLint is the bomb. Cool. Lynn, I think you're up next.
Sure. So this week I was working with some folks who were using Webpack for the first time, and they were looking at larger than expected file size coming out of Webpack. And I suggested using dead code elimination, which was new to them, and that reduced their file size in half. So I just wanted to make sure that people know that there is a thing called dead code elimination. It basically eliminates the code that your program is never going to touch anyways. So check that out to see if your tool has dead code elimination. And my pick is actually Dan Abramov's series on Redux on egghead.io. We are using Redux on Firefox DevTools, and so there are a lot of people who are new to it on that team, and those videos are going to be great for them. So thanks, Dan.
Thank you. Thank you.
Plus one to that one. Awesome. Brian, why don't we have you go next?
All right. I guess I have an obligation to shout out to Forward.js in February. You know, Ken, you're speaking, right? And we got Kyle coming, and I think Tyler will be there, and you know, everybody else should show up. So we should do one of these there. Anyway, that's what I got. Forward.js in February.
Cool, thanks. Dan, what do you have for us?
I don't really have any picks. I'm so overwhelmed at the second week at Facebook. So I'm like starting Mercurial and not really looking at JavaScript. So I don't have any picks right now.
Nice. Is that like an anti-pick for Mercurial? Or just kidding. Nice. Kyle, do you have any picks for us?
Yeah, just one, and it's very timely. It's happening like maybe even today in some of your cities. Hour of Code. If you're not aware of that, you should go check out, go look up Hour of Code. It's an initiative to teach, mostly targeted at high school students, but to teach people about coding, an opportunity to volunteer your time to help somebody else learn. So I think everybody should take that, and I especially would remind you that you don't really know something until you've taught somebody else, so that's a great way to do it.
That's awesome. Yeah, really solid advice. Matt Zabriskie, what do you got for us?
I was at last call JSConf this last week, and I don't know how to say his last name. Earl Castledine announced that his company is releasing something called GL React, where you can do in the browser WebGL or on like React Native, it'll use OpenGL. Pretty cool project for React. Thought it was pretty neat. As far as tips, I mean, Brendan already kind of hinted at this anyway. But as we talk about like the past, present, and future of JavaScript, just a plug for Babel.js, where it kind of allows you to use the future of JS in your apps today. If you're not already using that, you should definitely invest some time and look into it.
Awesome, thanks. Pam, what do you have for us?
All right. Well, I'm actually going to change my pick from what I wrote down, so it's more JavaScript-y. So I'm going to pick RxJS Next, so the next version of React extensions for JavaScript, so that they get a shout out in the first episode of JavaScript Air. And I also +1 to Kyle's Hour of Code. I did Hour of Code with a bunch of people today, and it's really great. So if you don't get to do it this year, definitely try and work with your local community to do it next year.
Cool, thanks. Tyler.
2 picks. I just added my second one. So the first one's going to be Matt Zabriskie's beard, because it is looking really good today. Second one is this really cool game called Flexbox Froggy. Basically, it allows you to learn Flexbox as you're playing this cool game. So I don't know who made it, but it's awesome. So whoever made it, thank you.
Cool. Yeah, +1 to the Matt Zabriskie's beard. It has a Twitter account. It's so awesome, so check that out. For me, just really quickly, I highly recommend that you just learn JavaScript. I think that's really valuable, and Brendan touched on that. So MDM has some fantastic resources. I'm making some Egghead.io lessons based off of some of those articles to talk about raw JavaScript APIs and DOM APIs. So learn that. And then my next pick is Plop. It's a Node module that is super awesome. You should check it out. It helps you like generate code, so like you can generate all the files you need for a React component or Angular directive or something. So that's that. I think we're going to wrap up. So let me just give a couple final announcements, and then we'll all say goodbye. So I'm totally lost on this Google Doc now. Yeah, sweet. So if you have any suggestions for future shows, we do have shows coming up, but you can go to suggest.javascriptair.com, and it will take you to a form you can fill out to suggest episodes and guests. If you have any feedback for us, feedback.javascriptair.com. That will give you a Google form to provide us with feedback. We appreciate it. And then, as always, follow us on Twitter, Google+, and Facebook to keep up with the latest. Next week's show is the same time, same place, hopefully on time, about learning and developing JavaScript with Ashley G. Williams and Kyle Simpson. And that's our show. Thanks, everybody, for tuning in. Thank you very much, Brendan, for taking the time to be on our show with us and answer our questions. It's awesome. Thanks, everybody.
Thanks.
Bye-bye.
Bye-bye.
Bye.